ENCMP students from the future. My name is Perez, and today I'll be giving you a walkthrough through what I did for my ENCMP programming contest and why I think you should join this programming contest. So basically, just like you, I was one day in my state thinking, oh, why should I join this thing? Well, there are lots of benefits. You get a lot of recognition online, just like I am right now through you watching this video, and you get to improve your programming skills as well as revise what you've learned so far in ENCMP. Uh, and also you like so basically what I did for my code was a line of four game, which was one of my favorite games as a child. It's basically like tic tac toe, except that whenever the players place anything into a particular column, their tokens fall all the way to the bottom of the column. So you could basically think about how that kind of algorithm will work. And another thing you have to do is you have to try and make four tokens match up in a row, in a column, or a diagonal. In the version 0 of my code, I basically implemented the basic functions of a line of four game, such as drawing a grid, allowing the players play when it's their turn, and checking if a particular player has had one at a particular point in time. I used matplotlib to draw the grids, which are basically line graphs, and I used matplotlib again to draw the players' plays, which are basically scatter graphs that are placed into particular portions of the axis. So you can basically do something right now if you really know how to use matplotlib. In the version 1 of my code, I improved the aesthetic appeal of my code by using making the scatter plots of the player's plays look kind of better and making the lines plotted look thicker. I also included a computer player that played random moves, like completely random. So it wasn't smart at all. And I implemented a condition for draws which didn't exist in version 0 of my code. So the code ended whenever the grids were completely filled up, but like no one had one yet. In the version 2 of my code, I decided to practice more on what I'd learned in ENCMP class. So I used matplotlib.patches, which is a submodule of matplotlib, just like matplotlib.pyplot is a submodule of matplotlib that basically draws patches like rectangles or text. So I used that to display, to tell the players when the game had ended and display who the winner was or if there was a draw. I made my computer smarter using a recursive min max algorithm. A recursive function is basically a kind of function that calls itself. So basically, if you have a function that prints something like hello world, and you after printing hello world, it calls itself, you could print hello world an infinite number of times, or you could have another parameter for the function, such as count, which could be 5, which makes the recursive function only call itself a particular number of times. So after something like 5 iterations, you get hello world printed 5 times and the function ends there. Finally, I included comments to make my code more readable. Just like in every single project, while making this code, I faced a lot of challenges. I tried to use my Pygame to make my game handle events like mouse clicks. However, I couldn't import Pygame into Spider. So my code basically, if in my code you basically impute a number which represents the column where you want to play your playing in, which is not as user friendly as it could have been. I forgot the logic of my code and many of the things I learned during ENCMP class. So this was kind of a hassle. And finally, many of the things I tried to do in this code were not taught to me yet. So I had to go to Python directories a lot to get information on those. Some of the things I learned is that just like any other project you might be doing, is advantageous to break this down into steps, which could serve as an algorithm to tell you what to do, so that towards the end of the project you don't get like worried about, oh, I've not yet done this. Another thing is that separating your code into functions is very very advantageous. Just like the body is separated into organs which perform similar functions, you could have functions in your code that perform similar functions in the code, just like how your brain helps you think or and learn, which are similar things. You could have a function that does similar things in your code. And I learned that it's okay not to have every single function that exists stored in your head. That's what Python directories are for. They could help you. And these are my acknowledgements. Thank you so much for your time.